Yeah, you use Wronskian matrix. Like in this case, just to be on the safe side, if I were you, what are they? E to the 2x and x e to the 2x for all x. And we're trying to see if those are linearly independent or dependent. If I were you, I would just evaluate the Wronskian. And you know how to do this? So e to the 2x and x e to the 2x, and then you take the derivative of this. Right, exactly. Which the denominator will be positive anyways.
Yeah.
So 3 e to the 2x, and here you have to do the product rule. So the derivative of the first is 1 times the second is this times the derivative of the second, which is 2e to the 2x. And now we get a matrix 2 by 2 matrix, and we can take the determinant of this matrix, and I'm sure you know how to do the determinant. Yeah, you crisscross this times this minus this times this, so we get e to the 4x, right? Because e to the 2x times e to the 2x is e to the 4x plus 2x e to the 4x minus 2x e to the 4x, because e to the 2x times e to the 2x gives you e to the 4x. Those two go goodbyes, and you have left e to the 4x. And as you know, an exponential can never be 0 unless x is minus x. So since the Wronskian is never 0, right? This is the Wronskian. Therefore, e to the 2x and x e to the 2x are linearly independent. Linearly independent. If the Wronskian is ever 0, and if you're trying to use linear dependency, if they're functions, you'd have to do it using the definition. You can't use the Wronskian. But if they're fundamental set of solutions, you could. So here, because the Wronskian turned out to be not 0, they are linear.
What do you mean?
What's your question?
What do you mean instead of this?
If they were, what I'm saying is, okay, so if you have two functions, okay, like f of x and g of x, okay, if you're trying to prove them linearly independent, versus linearly dependent, what I'm trying to say is, I mean, it's a little bit to the left. What I'm trying to But if they were fundamental sets of solutions, you understand? Meaning that they're solutions of the differential equation. You see? Solutions of the ODE, if f of x and g, if, so this is the other case. Let's write it in line. No? If f of x and g of x are solutions of ODE, whether you're trying to prove linearly independent or linearly dependent, you can use the Wronskian. That's what I'm saying. But if they're just functions, you'd have to use the definition to prove that they're linearly dependent.
So, all right. So if they're actually derivatives of a solution, if they're not the actual solution, or if they're like a derivative of it, on the proof goes, so
Yeah.
then that would
That means you would have to use the definition.
okay.
Like in this case, if those two are linearly dependent, I couldn't have used it. I would have had to use the definition.
Okay. But if it's not linear, if it would be fine that it's not linear.